Morning to you, sir. So tell us about this treatment. It sounds like something out of a sci-fi movie, but what in essence is behind this treatment?
So I think it's a fair description that it is certainly out of a sci-fi movie from the recent past. Historically, cancer treatments, we've used things like chemotherapy, which essentially come from often things like plants where we know they're toxic to the body and they kill all the cells in the body to some extent, but cancer cells turn over more quickly than most cells. So under those circumstances, chemotherapy is really not very specific at all, and it just targets the cancer because it happens to be growing faster than normal cells. And that's what we've been doing for really a long, long period of time. And over the last 10 or 15 years, that's changed to what we now describe as more like personalized therapy, where we've tried to identify targets that we can actually try and target cancer cells rather than just using a carpet bombing approach. In leukemias, which are immune-related cells, T cells and B cells, one of the ways of targeting those T cells is via this approach. Chimeric antigen receptor T cells, CAR T cells, are ways in which we alter the immune cells. So we alter immune cells essentially to fight each other. So we have immune cells that we've altered, which are able to fight the cancerous immune cells. And the unique thing about this work, which I think is incredibly exciting, is actually this is a cancer where they've found a very sophisticated way of getting these two immune populations to fight each other in your body. And actually, the cancer cells that we alter, we change their base pairs, and that's why that's why the name is given. When we change the DNA of the T cells fighting the cancer cells, we can make that balance favor the cells that we've altered. So it is an incredibly exciting and very sophisticated treatment.
Wow.
Yeah, so its name is base editing, and as you described, very sophisticated and exciting, and that's something we can all kind of understand from that brilliant description of it. The thing about chemotherapy, as you describe, is people get very unwell when they're undergoing that treatment because, as you say, it affects so much of the other parts of their body. People famously very, very sick when going through chemotherapy. What was Alyssa's experience of base editing? Did she feel well during the treatment?
So I didn't look after Alicia, but I'm involved in cellular therapies and these types of therapies. I work at St Bartholomew's, not Great Ormond Street. So these cellular therapies do have side effects.
Okay.
Because we are altering the immune system, inevitably we can get immune-related side effects. So you can feel like you've got flu when you're getting immune-based therapy. And sometimes if the treatment is altered in, and some of the treatments that we use outside of this, we can reintroduce immune-related diseases, and things like diabetes is an immune-related disease. You can get pneumonitis, you can get shortness of breath. So yes, you can get side effects from these treatments. The other really important side effect is that if your target that you alter is absolutely unique to the cancer, that's fine. But often your target may not be exclusively expressed on the cancer. It could be expressed on the skin as well, in which case you would get skin toxicity also. Now, this is a wider discussion and probably occurs less in leukemias because this is very specific to T cells. But as we move this treatment into wider areas, the exclusivity of the targeting is going to be really, really important.
It just sounds astonishing. This just makes me marvel at human ingenuity. And just to be absolutely clear, you talk about side effects, but this 13-year-old girl is completely free of leukemia, right?
Yeah, and we hope that continues in the future. There is we haven't yet seen the long-term outcome of some of these CAR T-cell therapies, and it would be premature at this point to say this is a cure for treatment refractory T-cell leukemia because it's only a relatively short period of follow-up. But the one thing that's different about immune therapies compared to chemotherapies in the past is if we re-educate our immune system to fight the cancer, we may be able to generate memory. And you might remember, like vaccines, when we're reintroduced by the same problem in the future, if that memory exists, your body can learn to fight the cancer. And indeed, the development of cancers originally is not just about abnormal cells arriving, mutations occurring and growing. There is a really key important balance between the immune system and the person about how the immune system can eliminate that cancer initially. So we've probably underplayed the role of the immune system in the development and treatment of cancer. And now, only now, with these ways, sophisticated treatments where we can alter the DNA to fight cancer.
Well, it's absolutely fascinating. Yeah, look, we all became sort of armchair experts, didn't we, in T-cell memory during all of the developments of the vaccine. So interesting to see it at play in cancer treatment.